Thank you for attending GIRD Systems' presentation on the communication system technology we've developed for the Navy under two SBIR programs, both in support of the Multiple Vehicle Communication System, or MVCS, for littoral combat ships. For N68335-23-C-0240, we're developing an antenna array for beamforming and null steering on unmanned vehicles to extend the range of operation and enhance link robustness. For N68335-23-C-0240, a Phase 2.5 program, we're maturing our anti-jam radio for insertion into the next block upgrade for MVCS 2.0. In this presentation, we'll discuss how our technology addresses the needs of the Navy, our approach to a solution, its status, and an overview of applications where technology transition is being sought. GIRD Systems is a small business in Cincinnati, Ohio, that develops advanced signal processing solutions for communication systems that range from novel anti-jam waveforms to the signal processing that enables communications in congested and contested environments. For the past 24 years, GIRD has been solving the military's difficult RF problems, and we have engineers on staff who have been solving these problems for more than 40 years. Our staff has experience designing advanced military waveforms for the DoD, with applications ranging from the MVCS mission to operations in jungle environments, to airborne unmanned vehicle networks. Our expertise goes beyond software and firmware development. We also design, build, and test software-defined radios, or SDRs, that can be targeted to mission needs for the Navy, Air Force, Army, as well as Special Forces. Recently, we've been developing a novel networked waveform and hardware solution for a proprietary commercial customer. With growing adversarial activity creating contested spectral environments, the Navy has sought to diversify communication pathways and improve the robustness of MVCS in support of littoral combat ship missions. A robust MVCS line-of-sight communication system leveraging a novel anti-jam waveform and antenna array processing is being developed to address this challenge. The improved radio system needs to provide the required throughput for mission success in challenging environments through waveform design and robust networking, while maintaining compatibility to the host ship and USV platforms. The waveform is complemented with an antenna array to enhance anti-jam operation and reduce the spatial footprint to reduce detection and intercept probability. Improvements to the line-of-sight communications provide the robustness and resilience required for operation in congested and contested environments. The anti-jam waveform enables operation at high jammer-to-signal ratios to maintain command and control to USVs as well as deliver important sensor data back to the ships. Further improvements are needed in the baseline anti-jam waveform, developed previously to provide additional features necessary for resilient operation, including mesh networking and advanced security functions. Robustness to interference is further increased through digital beamforming to further suppress interference on reception, in other words, null steering and spatially controlled transmissions, thereby improving covert operation. Under N681-049 and prior SBIR awards, we have designed a custom anti-jam waveform that provides flexibility in physical layer operation and channel utilization, while being scalable for application to other communication systems. It features automatic mode selection based on the channel and interference conditions, while providing frequency agility. The waveform is implemented on GIRD's custom SDR, which utilizes a modular, low-size, weight, and power architecture. The user interface was initially designed with a web-based backend, but is being replaced by a TAC-based user interface. Recent work has integrated support for the beamforming array, as presented on the next slide. The beamforming array being developed under SBIR N211-068 is initially designed to be mounted on the USVs to provide 360-degree azimuth coverage to ensure link service to and from the ship. It is composed of multiple panels in a cylindrical form, with each panel composed of multiple antenna elements to provide high per-panel gain, as well as better directivity and elevation. Each panel provides 12.25 decibels of gain, with a nominal 60-degree beam width, which improves to approximately 14.5 decibels gain, with a 24-degree beam width when beamforming with 4 panels. The array is designed to operate in S-band and to meet specific size and weight requirements. An initial prototype of one sector of the array has been produced, and its operation for beamforming and null steering has been verified through anechoic chamber testing. The anti-jam radio system developed under these SBIRs innovates at the physical layer, network layer, array design, and beamforming application. As already mentioned, the physical layer waveform provides automatic mode adaptation to adjust the modulation encoding while enabling dynamic utilization of the RF spectrum. The novel networking solution supports the network architecture of the legacy system while offering enhancements to promote flexibility and robust network connections. Finally, the array design enables complete spatial support for ship-to-USB communications with a simplified beamforming algorithm that does not require manifold information, thereby simplifying manufacture and installation of the array on the USVs. The N68335-23-C-0240 Phase 2 program is currently in the first option period, which runs through the end of April 2025 for the development of the array. Initial tests and customer demonstrations have shown the beamforming and null steering capability of a sector of the array. The complete cylindrical array is anticipated for first quarter 2025, with testing and demonstration to follow. The N681-049 Phase 2.5 SBIR program runs through the second quarter of 2027, in which waveform optimizations and other features such as mesh networking and security functions are being introduced in addition to the baseline waveform and hardware developed on prior programs. Multiple SDR and high-power amplifier units will be delivered for a series of field integration tests and demonstrations. A number of advantages and benefits result from the innovations applied to the radio waveform, both at the physical and network layers, and the array technology. While the waveform is robust to high levels of jamming and interference, digital beamforming provides further interference rejection while also limiting the spatial footprint of transmissions to improve the covertness of the missions. Automated radio operation removes the need for monitoring or involvement of an operator and maximizes performance for the operating conditions. Finally, the networking architecture, with the inclusion of mesh networking capabilities, provides maximal use of time and spectral resources, ensuring network connectivity and delivery of critical mission and sensor data. The anti-jam radio being developed on this SBIR program is targeted to the littoral combat ships MVCS 2.0 upgrade with our primary NAVSEA customers at PMS 420. Several prior and upcoming tests are preparing GIRD's anti-jam SDR platform for this transition. However, due to the flexible and scalable nature of the waveform, it can be scaled for application to any communication system that needs improved robustness with high throughput in the face of interference or jamming. We are looking for partners with such needs and would consider licensing of the waveform to third-party providers. Thank you for your attention during this presentation of the robust communication technology we are developing for the Navy. Our contact information is included here for your reference. Please stop by and see us at our booth at Sea Airspace 2025. We would be happy to discuss how to apply GIRD's technologies to solve the DoD's most difficult communications challenges.